Okay, so the next question, let's move to the next question, question number 6. Let's see what the question is about. Okay, we can see a circle there with a triangle inscribed within it. Okay, so figure 2, the shaded area in figure 2 shows the plan view of a helicopter landing pad. Okay, well, so this is a plan view for a helicopter landing pad, so which we see frequently at the top of high-rise buildings. Okay, the area consists of the major sector AOB. Okay, AOB is a major sector with circle center O joined to the triangle AOC. Okay, AOC is a triangle which is connected with the major arc AOB. Okay, fine. So given that AO equals to OB, this is 15 meters. So AO it is 15 meters, and BO it is also 15 meters. Fine. Then the CBO is a straight line. Okay, CBO is a straight line. We can see a point C here. So this point has been found by extending the radius OB outside of the circle and making it to a new point outside of the circle, which is point C. And this length BC, it is 2 meters. So total OC, it is 17 meters. Okay. Now part A is asking to show that angle COA is 1.847 radians. We need to consider up to 3 decimal places. Okay, fine. So okay, another thing I missed out from there, the angle ACO, it's given as 0.6 radians. 0.6 radians. Okay, fine. So now this is a question from uh, it's from radians chapter, but here you need to apply the concepts of trigonometry like sine rule, cosine rule, these stuffs. Okay, so uh, we know that if I talk about the cosine rule, for cosine rule we need, if we want to find out the angle, okay, then we need to know the 3 sides of the triangle. Okay, or if we want to find out the side, then we need to know the length of the two other sides and one angle that lies between the known sides. Okay, so this is for the cosine rule. And for the sine rule, uh, we need to know uh, 2 pairs of side and their opposite angles. Okay, it's not necessary to have known both the opposite angles, because if one is unknown we can use the sine rule to find out the unknown ones, but it's must that we need to have two pairs two pairs of side and angles. So side and angles, the angles or the sides, it should be opposite to each other. As for example, if I consider this angle, the opposite side would be AO. So in this case, it will be sine 0.6 over AO. Okay, this is equals to, if I consider this angle, let's say this is angle O, which is theta, we need to find out. So I considered this as theta. So sine theta over AC, and this is also equals to, if you consider this angle, which is alpha, so sine alpha over what, the opposite side, which is OC. This is the sine rule. So which one to apply here? You need to think like what angles or what are the sides we know here. So we know this side 50 meter, right? And also we know its opposite angle, which is 0.6 radians. Fair enough. We know this side, which is 17 meter total, but we don't know the opposite angle, which is I considered as alpha. So alpha is unknown here. Okay, so this is the case for sine rule. if I have to if I need to think of the cosine rule here, I can't, because I know only the two sides and an angle. But the angle that I know here, it's not between the known sides. So I can't apply cosine rule in any way. Okay? So take it out from your head. Just consider the sine rule. Okay. So using the sine rule, we will approach using the sine rule. So sine theta, that's the unknown angle. That's sorry, it will be alpha. Sorry, that would be alpha, alpha, alpha. This is alpha. Okay. So sine alpha over the opposite side, which is 17 meters. You can see this is sine alpha. The opposite side is 17 meters. Sine alpha over 17. This is equals to sine 0.6 radians. Okay, keep in mind the angles is in radians, so don't forget to convert your calculator mode to radians. Okay. Okay, so now we need to just find out the alpha. So sine alpha equals to, okay, I think I need to, okay, my calculator is in radian mode. So sine 0.6 times 17 over 15. So that is 0.639928135. I always like to keep whole decimal values, whole decimal number, so that my answers match perfectly with the mark scheme. Okay, so you can try this too, but you need to be fast definitely. So sine inverse of the answer, it is the angle alpha. We got 0.694404747. So we can see it's not quite much different from the sine of the alpha. Interesting. Okay, so we got the alpha. Now the question is asking for the angle COA, that is the theta, and we know that the sum of the three angles of a triangle is 180 degree, which is pi radians. So we will use that concept. Okay, so angle AOC plus angle ACO plus angle CAO, this is equals to pi radians. Okay, so we need the angle AOC, which we considered as theta, right? So theta equals to pi minus angle ACO. Okay, is it angle ACO what we found? ACO, it is 0.6 radians, so 0.6 radians minus this angle, which is what we found earlier, 0.694 something radians. Okay, it's saved in my calculator, so I don't need to write the whole figure here. Okay, so pi is 3.1416 minus answer minus 0.6, so you will get 1.1.8471952557 radians. Okay, so angle AOC, this is equals to up to 3 decimal figures, decimal places, it is 847 radians. That's it. That's the answer for part A. Fine. Part B is asking to find the total area of the helicopter landing pad, giving you answer in meters squared to 3 significant figures. Okay, we need to find out the area of this helicopter pad, landing pad. Okay, so this shape, we have to divide it into 2 parts. Okay, as I said at the beginning of this video, this that the angle, the circle we are considering, this is a major arc AOC. Okay, AOB. So this AOB is a major arc. We need to find out its area separately and the area of the triangle separately. And for the area of triangle, we know that the formula half of what? AB sine theta, whereas AB are the two adjacent sides of the angle that we considered as theta. Okay, AB sine theta, that's the formula. So AB must be the adjacent sides to the theta. So since we know this theta, right, we got it, we just found it, so we will use this theta, and we know the adjacent two sides. Okay, 17, 15. Okay, so let's find out the area of the triangle. Write it first. Area of triangle AOC equals to half of AB, which is 17 times 15, times sine theta. Sine, we got 1.847. It's not the exact value. Okay, so use the exact figure from your calculator. So I have the value saved in my calculator, so I can use it just using sine answer. Sine answer, then times 17 times 15 times half. So the total area, it is 122.660658.5 meter square or centimeter square. I'm just confused. Let me check. It's meter square. Okay, fine. Now the area of the major arc. So the area of an arc, it's not an arc actually. The AB is a major arc, but AOB is a major sector. Okay, major sector. Consider the difference. So for the area of the major sector, it is half r squared theta. Okay, so we know remember, this theta is not that theta. Okay, let me change it. Consider this as a different thing. Let's say beta. Okay, okay, so half r squared times beta, which is the angle, major angle AOB. Okay, so radius, we know the radius is 15. So area of the, we can write it easily here. Area of major sector AOB is half r squared theta. Theta is basically 180 degree pi minus the beta. Beta is pi minus the theta, which is 1.847 something, that much radians. Okay, so just find the value. I'll use the exact figure. 1.847195257. That's the theta. So 3 point. Okay, I'll save it, and then 3.1416 minus the 1.847 that I saved as answer, times 15 squared times half. So this is 145.6205336, that much meter squared. Okay, so total area, we will get 122.66 dot dot plus 145.62 dot dot, that much meter squared. Okay, so the total, you will get 122.660658.5 plus the answer that we saved earlier. So this is 268.2811921 meter squared. We got the exact value. Okay, so we just need to round it to the the wanted significant figures. 3 significant figures the question wanted. So we will round it to 268 meter squared. That's the answer. Simple. Okay, next one, find the perimeter of the helicopter landing pad, giving your answer in meters to 3 significant figures. Okay, we need to find out the perimeter. Perimeter, it means the border length. Okay, so perimeter, it has to be also divided into some parts. Okay, so we got the major arc. Now it's major arc. Okay, because we are talking about the border. Okay, so the major arc AB, we need to find out that's length. We know this BC. Okay, and we just need to find out the side length of the triangle AC. Okay, so we can find out the length AC using the sine rule. Again, sine rule. Okay, so let's consider in the triangle for part C, in triangle AOC, sine theta. Theta is 1.847 dot 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 radians. Okay, over the opposite side is AZ. That's what we need to find out. Sine 0.6 over the opposite side 15. No worries, I'll show you now in the figure what I have considered. I considered this theta, okay, and the opposite side AC, because I need to find out AC. I know this theta, which is 1.847. I found it in part A, and I considered this 0.6, okay, sine 0.6 and its opposite side 15. Fair enough, okay. Now just find out AC, okay. So it's sine 1.847195257. Okay, that's the sine theta. Okay, so if you make AC the subject, so sine 1.847 radian times 15 divided by sine 0.6, so you will get 25.5571736 meters. Okay, we got the length of AC. Now we need the length for the major arc AB. So we know that arc length is r theta. So the radius of the circle, it is 15, and the theta, it is pi minus 1.847. Okay, it should be dot dot dot, isn't it? Okay, so that much radians. So pi minus 1.847, 1.847, correct. So pi 3.1416 minus 1.847195257, then multiply it by 15. You will get your major arc length, which is 19.416071115 meters. Okay, so the perimeter, we will get 19.416 dot dot dot, okay, plus 2 meter, the length of BC, plus the length of AC, 25.55 dot dot dot, that much meters. Okay, so the total length, you will get 19.416 dot 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 plus 2 plus 25.5571736. The total is 46.973244755, that much meters. Okay, so up to 3 significant figures, you will see this is 9, right? And the next figure, it is 7, which is more than 5. Okay, that means if you round 9 up, we need to round 9 up, since the next figure, it's greater than 5. So the next figure, it is, so if you round 9 to up, it will become 10. That means we will have a 0 in this place. Okay, and the extra one, it will get added with the 46, so it will be 47.0 meter. That's the answer. That's it. Okay, so hope you understood, and yeah, that's it. That's all about question number 6.